All right, welcome to episode 12 of Progress and Liberty about nuclear power. Now, this is kind of a reply video to Kenneth Katona, by the way. Can I still call you Star of Sagittarius? I like that handle, but you moved on from it, I guess. Call you by your channel name. It's also just a general statement. So I linked Kenneth's video. You should go watch it. But also, it's a general thing. He's saying why. I asked him why he thought that nuclear power had too many drawbacks. What were those drawbacks? Now, here's the thing, Kenneth. I think basically this is something possible, to research um, and find something different out about it. Um, Basically, there's a couple things that can free up preconceptions that we have. Not all the preconceptions are going to be wrong. Of course, there is radioactivity in nuclear power and stuff. But there's a lot of, nuclear processes are basically chemical processes. So there's as many different ways of doing it as there are chemicals, with the possible exception of being you have to use thorium or uranium as your fuel, or, if you produced plutonium and stuff like that, you could use it, but no naturally occurring plutonium is radioactive anymore. So you would have to make that. The only two elements on Earth that are radioactive is a little tiny bit of uranium and pretty much all of the thorium. Okay, so the first thing to realize is that with all of these hundreds of different kinds of nuclear processes that you could build energy, nuclear turbines and nuclear reactors of various kinds around, we've only really tried one basic design that was modified a couple times, modernized, but basically this one design, and it was the design that was chosen to make nuclear submarine reactors. Okay, that's why they're really water hungry and whatnot. None of that is necessary. Okay, so there's other ways to make the plants. Now we call the ways being developed right now Generation 4 nuclear, and I've talked a lot about the diagram that I just had up, which is a liquid salt reactor. But there's all high-speed gas jets. There's, taking a little piece of nuclear material and shooting it with the laser so that you can burn it, really slowly. And go, these designs do things like the ability to shut down the reactor without needing electrical energy going to generators to pump water and cool things. They all have ways of doing that, right? And as far as meltdowns, like the Fukushima meltdown thing, that doesn't have to happen at all. I mean, first of all, it doesn't have to happen um, uh, with a running reactor. It sure as hell doesn't have to happen with that spent fuel that needs to be cooled for so long. Okay, now why is there that spent fuel? This is the problem that Kenneth talked about, is this waste, and the problem with the waste, and the fact that in this design we use, you have solid fuel rods, and after you get about 10% of the radioactive energy out of them, they become contaminated and useless. But Kenneth, you said, it's beyond repair, that situation. No, that's a factor of the design, that those things want those rods for various reasons that made a lot more sense in the 50s than they actually make right now. But even then, it's dubious, because one of the reasons they wanted this reactor design with uranium was so that they could make plutonium and enrich radioactive materials to the point where they could be used in nuclear weapons. And of course, a lot of nuclear energy, efficient nuclear energy designs, are not about creating really hard to handle, even heavier, more radioactive elements. They're just about getting the energy out. So as a result, you have a lot of different ways to go about this. I mentioned with the gamma laser, but you can also use the liquid fuels. If you dissolve the radioactive fuel into high temperature salt, it can all get burnt up. You don't have to leave 90% of it in the waste pile. And when you burn it all up, you don't end up with radioactive material that lasts 10,000 years. You end up with radioactive material that lasts 100, 200 years. And a lot of them that just last a few hours that are useful in in medicine, for example, in medical imagery now. And those right now have to be made in a special purpose, very expensive reactor. So uh, furthermore, you get things like the only way to make helium is through nuclear processes, and we actually get helium that's trapped in rocks that we crush, and uh, we could actually be producing helium, and it doesn't stay reactive for, I don't know, a very short period of time. When it comes out of a reactor, I think most of it comes out probably non-radioactive, actually. But don't quote me on that. You have to look it up. The point is, we have in a nuclear reactor, we have the ultimate chemical laboratory that ultimately you can use a lot of that energy to create chemicals. And that's what we use a lot of energy for right now in our manufacturing process is, to melt quartz, mix it with, carbon and get, silicon wafer material or whatever. So the fact of the matter is, if you use, which we will, I'm sure that we will, when we use our next generation, generation 4, 5, or whenever it happens, nuclear power, because remember, these aren't just ideas. These hundreds of different reactor designs, if not thousands, have been built over the last 50 years all across the world in research facilities. But that fuel that is now waste, that was your main complaint, that can actually be melted down into the liquid salts and used as fuel. So they're working on designs right now. They're about to commission one of these Generation 4 nuclear reactors on a government level, and it might not be liquid salt. There's other ones in the running for this test bed reactor they have coming up. But they will be able to use all of this waste we've been trying to put in mountains in Nevada and wherever. That's actually fuel. It's actually thousands of years worth of fuel. So the danger of nuclear power in terms of its waste, it's like, dude, over the 50 years of burning gas for electricity, we've literally put, billions and trillions of tons of carbon, uh, poisonous carbon, carbon monoxides and things into the atmosphere. Like, that's actual stuff. It gets aerosolized and floats away in the atmosphere, but you could also have it in the form of ash, and it's literally a trillion-ton pile, just like you would expect a trillion-ton pile to be, right? Compared with even this ridiculously primitive design of our current nuclear power, um, it didn't put stuff in the air. Hardly anything at all has gone into the air. Practically no radioactive material has gone in the air. And the biggest problem with its output is that it's sitting in barrels right there, and it should be used as fuel in a nuclear reactor. And we just need a nuclear reactor that was designed to give us the free energy that nuclear does provide, almost free energy, instead of one designed to make a nuclear weapons Cold War or to win one. So thanks for your video. That's my reply on those basic issues. And I've been talking about this for 8 years, and it's gotten way huger than when I first talked about it. A lot of actual reactors are going online. A lot of actual research has been started up. They're studying all these different kinds of salts to figure out which one to use. And as I said, there's also these high-speed jet and gamma laser-driven processes. And basically, you need that because renewable doesn't compete with gas because, one, until we have the magic batteries, which they are working on, but until we have those, You can't have guaranteed service. That's a problem. And then two, you have to make those windmills, and they're giant machines that wear out in 10 years, right? In California, the giant solar farms is such a reflective thing, it's burning birds as it flies over. Now, they might be able to have a better matte finish or something. But the point is, you're using thousands of acres for stuff. It's not going to be totally neutral. Nothing's totally neutral. What you need is something that doesn't use too much space and something where the poison that comes out of it can just be collected to the side. If you could collect it to the side, those poisons could be chlorine that you use in your chemical process, and they're not poisons. You just have to be careful with them because, like many industrial materials, like even dyes or whatever, they have to be handled with care, right? But they're right there and you can handle them. You don't want systems where it has to go out into the environment. And nuclear is I'm also green, always have been. I think we should clean up all the Superfund sites. I think we should drain Hetch Hetchy. Nuclear power is a carbon neutral power source that can help do that. You know, I'm also anti-pollution, so I don't want to burn, carbon fuels anyway for jets and rockets or anything that isn't going to be electric anytime soon. But if we have to, we can distill those carbon fuels out of seawater with nuclear because nuclear power will be so cheap. Already is cheap, but this generation 4 is going to make it a lot cheaper. And when you burn fuel that you've distilled out of the ocean, the carbon gets absorbed back into the ocean and it's carbon neutral. Now, unfortunately, you've put carbon monoxides and bullshit in the atmosphere. It's not all okay. It's not okay for the ozone or whatever. But if we're making incremental improvements, then this is what we need to look at with the actual facts and numbers. And while nuclear meltdowns are not acceptable, we should shut down every nuclear plant that's susceptible to that, which is pretty much all the nuclear plants, well, all of them in the United States that are commercial. But we should replace them with modern nuclear plants that have the ability to not be designed such that the meltdown is even possible. One major thing is don't use the uranium cycle, use the thorium cycle, which is lower energy. And it doesn't run away. The thorium cycle naturally wants to come to a stop because thorium only puts off one neutron. So you actually need to have some salt it with some uranium or shoot a gamma laser or something at it to create a little bit of seed to get the domino effect of the reaction going. And on its own, it would dissipate. But of course, that's not the safety mechanism because, hey, you could put so much fuel in there that it does start to overheat. The safety mechanism in the case of the salt reactors is that salt has known temperature properties, right? You can make a different salt plug for your liquid salt reactor where if your main fuel salt gets too hot, it melts that plug and dissipates it into a pan. You can't do that with solid fuel rods, 10, 20 feet long. And you can't really do that with pellets and stuff either. But even with solid fuels, there's a lot safer things that people could do with pebble bed reactors and stuff. We don't have to have these problems that we have because it was the 50s and 60s, and we were more concerned about winning the Cold War, and we didn't have the kind of mechanical science now. We have robots now that can do totally way more sophisticated things than we need in order to achieve the safety that they were trying to get by having big, heavy fuel rods that could be moved, down to an inch at a time. So, all right, that's my message to all of you, and especially Kenneth and all viewers, new and old in this case. I'll just leave that comment up there. That's interesting apropos of wet snow. Saw you were making some videos late. I didn't see that, but this comment of Kenneth's was from maybe my very last video where I talked about Michael Moore Presents that documentary. Different guy made it, but and it goes into all of that about how the solar the solar fields in California actually took more coal in both in energy and in actually using the coal to get carbon for the silicon chips process or something like that, that you could have just gotten more, that you'll never get that energy back in the life of the solar thing if it's going to be 20 years, because if you would have just burnt all that gas, you would have got more energy. So I don't know if that's true, though, by the way, exactly true. But there's a lot of things in that that are true. The main thing is until we have magic batteries, and there's some interesting ones with molten metals and things where you could have a really efficient battery that doesn't lose, basically a kind of a capacitor you want to make that doesn't lose leak charge, um, or leaks, a little bit enough that you can keep enough power, to keep the city going when the wind isn't blowing. And even that could be a little bit iffy. I mean, you really want something where I have the fuel and the people, the facility, I have power. Um, so I think we're going to need nuclear even if we had the magic battery. But I also think that magic batteries might be a little bit toxic to manufacture and whatnot. And people are going to find out that nuclear facilities, because there's so much energy concentrated, are actually very small. The amount of waste is very small. All you have to do is be careful keeping it running, use good engineering. And they're so small, they take up such a tiny amount of space. I mean, they got you know how this works, right? Like the nuclear aircraft carrier. It just has one load of fuel, right? It's just like a big battery. They use it for 30 years or something and then swap it out with another one. It doesn't have to get refueled. I mean, it's just amazing. And so that's enough power to power a small town for 30 years without a new fuel delivery. So, yeah, it's nuclear war in our warlike nature, and it was probably too early to go into this in the 50s and 60s or 30s, certainly. But I think we're ready now, so let's do that. All right, cheers to everybody. I hope you're doing well in this COVID crisis. I feel for you all. I feel like, I'm by a thread, but I already worked at home and stuff, but that doesn't mean that the people because I have my own business, but I contract, so if my customers have a tough time, I could have a tough time. And so I know that times are tough. I have my cousin and his wife are out of work. Um, Luckily, they're getting the unemployment, the bonus style unemployment, but he hasn't got it yet. But yeah, so I know it's tough. Hopefully, everybody's hanging in there and doing okay. Not much more to say about that in a video like this, I guess. But boy, what a can of worms. But we need to just to keep in sight of what's really going on. Let's just put it that way. Not warp it into like that it's some part of every other conversation we're endlessly having. Cheers.